Hello and welcome back to the shop. Today we're going to take a look at a tiny little blower. And this is a tool that is not an official Milwaukee tool, but it is made to operate on a Milwaukee M18. So this is your typical Chinesium branded cheap tool, and it's just supposed to be a little blower that you can use in the shop or anywhere to blow dust or any sort of other dirt around. They call it a leaf blower, but I don't know that it would be very effective at that. But it's just this blower, and it comes with an additional nozzle. And I thought we'd take a look at exactly how it works and how well it works. To help us out with that, we're going to use a digital anemometer that we have here in the shop, and hopefully we can see if their wind speed claims are accurate. You can see this thing's got good bearings, it's already turning. So let's get into it. So this thing has an on-off switch here, and this other button which selects which speed you want. There's 4 speeds, and I gotta say, it does work fairly well. There's some things on the label here that are of note. I believe that possibly you can use this to turn dogs into superheroes, maybe? That might be what's going on there. They're showing air coming in, going through this thing, and then your dog is a superhero. Either way, that is a fairly epic cartoon, so props for that. So let's get into it here. So we'll test it with both nozzles, and I think what I'm going to have to do is hold the tool kind of like this so that you can read the digital display of the anemometer. So let's fire this thing up. There we go. And their claim is meters per second. And you can see we are indeed set to meters a second. So let's look at what their claims are. Okay, so they are claiming that this thing can go up to 130,000 RPM. That's moving. First speed is going to be 8 meters a second. Second speed 17. 25 meters a second for third. And the fourth speed is 30 meters a second. That's some air moving. So let's see how accurate any of that is. So I guess what we'll do is we'll start out by holding this. Let me turn off the fan that's in the shop so we don't affect our readings at all. Alright, so we've got the fan turned off in the shop. Let's just get started, shall we? So let's fire it up. This is low speed, I believe. And I'm going to go perpendicular, trying to see if distance makes a difference here. About look, the best I can get is around 6. That's perpendicular with the anemometer. 6.22. They claimed 8. Now if I change the angle to allow more air to hit the fan blades, we can get it close to 8. So that's probably what they were doing. They were probably holding it out an angle. And the way that works, let's let that slow down here and we'll see. That's probably what they were doing to fudge the numbers. But what we're doing there is you can see the angle of the blades, and by holding it on this angle, we're getting more surface area on it. So we really want to be this way, perpendicular to it, to get an accurate reading. I don't know if right on it is the best or not, but so first speed, we were able to duplicate what they had. Let's see, for the fun of it, let's change tips. Take the round tip off, and we'll put this more focused one on. Maybe they use the focused one to get the better or higher velocity readings. So let's see what we get here. So that seems to be lower, at least with this anemometer. Yeah. Yeah, that seems to be lower. Let's just, for science's fact here, let's just run it without any tip on it. So that's just a big hole there. And in the hole, while we're at that, you can see, as it's blown out, a little bit of circuit board and the motor. This is a 3-phase motor. It's brushless. You can tell by the 3 leads going to it there. So it's a 3-phase motor. There you go. You can kind of see them better when I'm not blowing it out with the flashlight. And permanent magnet DC motor or AC motor. There's the impeller blades there. I marked them with a Sharpie in an attempt to be able to try and read RPMs, and that didn't work out for me. So we're not going to be trying to double check the RPMs. But let's keep going with what we got here, and let's see if we get a higher velocity without any tips on it. Now we get a lower velocity still. So the best tip for testing is going to be this one, the rounded one. This one here. And the diameter of this, in case you're interested, I should have a scale somewhere here. There we go. The diameter of this is just about 3/4, pretty much right on 3/4, which ought to be about 19 millimeters for those of you in the rest of the world. Let's see what we can do here now. So I believe the spec was, wait for it, the spec was 17 meters a second for second speed. So let's see if we can get close to that. So, and all we'll do here is push the button and hold this perpendicular. So I didn't try to talk over that. I probably couldn't be heard anyway. So that you can see we're getting like 14 to, I could peak it at maybe 15. So they were saying 17. You saw if I held it on the angle like that, I was able to push it even up to 18. So it's a little lower than what they had said, but I think they were maximizing blade surface tension to get that as high as they can. So the next speed is going to be 25, if you remember. Let's shift it again here. So all we do is turn it on, and we hit that. And we're able to get to be right around 23, which is quite impressive. That's a lot of error. So one more test here. Let's hit it. We're going to go to crank it up to 11, which is actually 4, but we're going to see what she does. So on the high speed, we could get about 27 out of it, which is damn impressive. I mean, this thing really does blow air pretty good. I mean, you probably see if I hold my hand out. You can see the old skin getting blown around there. It's not nothing. This thing actually blows pretty good. And I find, I've been playing around with it here in the shop, I find the second speed is almost perfect. So let's get it down on that. The second speed is almost perfect for just blowing dust off of stuff. I think if you were cutting with a saw and you just wanted to blow your dust away, 1 would almost be perfect. You don't really need it screaming, you just need it to move some dust. So if you're going to use it in the shop for clearing off a workspace, you know, or just incidental blowing dust off of things, or anything like that, it's going to work relatively well. So, and you'll see that the head of this thing is really not that big at all. I mean, overall length on this thing is 5 inches, so it's really not that big. It relatively, I mean, this isn't glass fiber reinforced, I bet. This is probably just regular ABS sewer pipe plastic, but honestly, it's pretty darn good. I was surprised at its performance, and hey, sometimes you gotta try to know. Okay, so I decided to do one more test here. This is actually, I'm shooting this after the regular video, but I think this is kind of important. I was thinking about, a lot of times, one of the more important things is actually low voltage shutoff. It protects your batteries, it keeps them from getting damaged and everything else. So what we're gonna do here is we have the power supply hooked up. I have it cranked up. This is only a 30 volt 5 amp power supply, so I don't know if we're going to be able to run the tool full bore or not, but we should be able to get a good representation. So what we're going to do here is we're going to turn the tool on, and we're going to run it down to see where it turns off, and then maybe we'll run it to at least the next speed. I don't know if we'll be able to run the 3rd and 4th speeds because we're only a 5 amp supply, but let's do that and see what we get. So we have positive and negative hooked up from the power supply. We're just going to turn this on. So just about 5/8 of an amp, a little over half. Let's go to voltage set. We're going to go down by tenths. 19.9. Now I think your normal voltage cutoff is anywhere around 14 volts. You can hear it slowing down. We don't have a lot of, well, it's not drawing more current. 15 volts, 14.5. It should be somewhere in here we ought to cut off. 14.3, 14.2, 13.9, 13.8, 13.7, 13.6, 13.3. So right at 13 volts, 13.2 volts at cutoff. So that seems a little low. I forget what I metered some of the other stuff cut off at. We could probably get something Milwaukee and see if we could duplicate and see what voltage it shuts off at. Okay, so we have an actual Milwaukee tool hooked up here, and it'll be a light. Have the power supply off right now. I'm going to do voltage set and take it up to 20 volts again, so that we are doing the exact same test. Okay, 20 volts, turn it on, turn on our light, and then what we'll do here, since we have a nice visual, is we'll just turn it down. And we're getting down to 16 volts, so that's a big difference. Let me turn that back on again. Might be too low. Okay, here we go. Let me do that slower. 18, 18.6, 18.3, 2, down to 17 volts, 17.5, 4, 3, 2, 1, 17 volts even, 16.9, 16.8, 16.7, 16.6, 16.5, 16.4, 16.3, 16.2, 16.1, 16 volts. So right at 16 volts that wants to turn off. So that's a big difference. That's something to keep in mind with aftermarket tools like this. Your M18 batteries from Milwaukee, the low voltage cutoff circuit is around 16 volts. Now I think another project that we did here, we had it at 15.4 was the highest I could go with the shutdown circuit that I had. So anywhere around there, 16 to higher 15s to or so. This being at 13, that's kind of low. So maybe it's because it was a lower draw, though this light was a lower draw than that. Let's run a higher speed now and see if we get anything different. Maybe it'll shut down a little bit quicker on a higher speed because there's more current draw. So let's take this back up to 20 and we'll come down from there. Okay, right at 20, power supply on. So now we're on speed 2. You can see we're drawing more current, 2.25 amps, and now we're just going to start going down. $18 amps or volts, 17 volts, 16.5, 16, 15.5, 15, 14.5, 14 is still 13.5. So we went off at 13.3. So it's still around the same range. That's not necessarily the best thing. I think that's probably a little low. But I don't know if it would really damage batteries, but it's not necessarily the best. So we'll do it one more time here. I think I can run it on the third speed. Let's see what we get. So the third speed, you can see it wants to blow the tool around. It's got the amperage pegged. $16 volts. $15 volts. 14. So 13.4 seems pretty consistent that it's going to turn this off. I think if I was using this tool a lot, and what I will be doing is I'll probably be checking the battery myself. That's kind of low, and I've seen that before with other Chinesium type things. There's these knockoff 12 volt outlet things. I didn't mark the cutoff voltage on this one. Some of them I did. This is just like your heated gear type adapter, USB charge. All of those types of cheap things, I normally check what the voltage cutoff is before I start ripping with batteries, because you just never know and you don't want to damage your tools. So I thought this was an important segment to add, so let's go back into where we were at. Hope you enjoyed this. Tried to keep it a little shorter. Just a quick look at this mini leaf blower. It's just a little blower. We could compare this to the other Milwaukee blowers if there's interest. It's kind of interesting to see some aftermarket tool ideas coming out now. This is not at all a Milwaukee. This is not even a copy of a Milwaukee. This is just a tool that clips onto a Milwaukee battery that somebody came up with, and I think that's pretty cool. So, hope you enjoyed this. Thanks for watching, and as always, have a great day.